Welcome back to Inspire AI, the podcast where we explore the ideas, technologies, and leadership principles shaping an AI-accelerated world. We're here to help you think more clearly, lead more confidently, and prepare for what's next. So today we're going to explore a concept that I believe is going to become one of the defining principles of AI-enabled software development. In case you hadn't heard of it already, it's called loop engineering. And if you spent any time on LinkedIn over the last year, you've probably seen a lot of conversations about prompt engineering, but the conversation has shifted toward AI, and everyone seems to be building autonomous coding systems capable of writing software, fixing bugs, and even creating pull requests. At this point, the team seeing the biggest productivity gains aren't simply writing better prompts. They're designing better systems. Systems that give AI clear objectives. Systems that verify the work, that learn from mistakes, and that know when to stop. And if you put all that together, that's essentially what loop engineering is. So let's dig in. I alluded to a moment ago about prompt engineering shifting to systems engineering. You see, when generative AI first appeared, success came down as asking better questions. A better prompt produced a better answer. But coding agents change that game. Modern AI agents don't just answer the questions. They interact with repositories. They execute commands. They run tests. They inspect logs. And they call APIs, all while editing multiple files. And they can be tasked to work for hours before asking for human feedback. So you can imagine that writing clever prompts isn't going to be enough to manage that sort of system. And the challenge becomes designing the environment those agents operate within. Think about it this way. If prompt engineering teaches an AI what to do next, loop engineering teaches an entire system how to decide whether that work was actually successful. So it's a different problem to think about. The simplest way to consider what loop engineering is, it's a discipline of designing feedback systems around the AI. So instead of dropping into Lovable or Claude Code and saying, I want you to build me this, you have to ask, can the entire system repeatedly produce correct software with minimal human intervention? Every iteration follows the familiar pattern where AI receives a task, it creates a solution, and the system validates the solution. If the validation fails, the AI receives structured feedback, and then it tries again. Not forever, and definitely not blindly. Just enough to improve the outcome before escalating to a human when necessary, or calling its job done. It's kind of like managing a high-performing engineering team. You give them some instruction, and you expect them to iterate on that until it's complete correctly. Now, if you give them bad instruction or ambiguous instructions, well, that's on you. So what shaped loop engineering around the coding environment? It just so happens that software engineering is one of the best domains for AI because success can actually be measured. If a test passes or fails, if static analysis succeeds or doesn't, if security scans identify vulnerabilities or don't, applications as well can either be built or they won't. Unlike many creative tasks, software provides objective feedback. The feedback is the fuel for the continuous improvement. Now, you can probably see why there are so many organizations investing heavily in AI coding agents, because these environments are near perfect to supporting learning through iteration. So what is it like to create a great loop, if you will? There are several essential components to loops. First, there's the prompt manager. It's not simply a system prompt. It's the responsibility to provide the agent with context, project documentation, coding standards, and clear success criteria. Then there's the agent runtime. This is where the planning happens, where tools are called, where code is written, and repositories are explored. And finally, not to oversimplify all of this, one of the most important components is the verifier. This is where you run unit tests, type check, static analysis, security scans, even UI validations. Whatever objective evidence exists to determine whether the work actually succeeded, that's for the verifier. And then you have the looping agent or the rerun controller. Its job is pretty simple. If everything passes, you're done. If the failure is understandable, you retry. If uncertainty grows, it escalates to a human. So you might have noticed in that loop that the AI itself isn't making all the decisions. It's really about the system that the AI is inserted into. That helps it make those decisions properly. Here's where it all becomes rather fascinating. As AI becomes more capable, the engineering role will change. We'll spend less time writing every line of code ourselves. Instead, we'll spend more time designing environments where AI can succeed. We build documentation, define the policies, and create the tests. We can improve observability, we can build evaluation suites, and we can capture organizational knowledge. But as AI becomes more capable, engineers are going to spend less time programming and more time engineering these learning systems around the loops that have been described, which creates a profound shift and a true competitive advantage. Because many organizations assume their competitive advantage will come from choosing the best model. GPT over Claude, over Gemini, open source alternatives like Kimi. History suggests something different though. The strongest organizations almost always win because of the systems, not the individual tools. Think about Formula One, for example. The fastest engine alone doesn't win championships. It's about the entire pit crew, the telemetry, the strategy, and the feedback, even the timing of all of those systems together. They create consistent performance. AI development is definitely heading in that same direction. Eventually, I imagine every company will have access to extraordinary models, but what will separate them will be how intelligently those models are embedded inside the well-designed feedback loops. Here's some lessons from the industry. Throughout my research on this topic, some of the most advanced AI engineering teams have reached this conclusion. Rather than focusing exclusively on larger models, they're investing in better evaluation, better testing, persistent context, structured documentation, observability, and measurable feedback, all while running long execution environments. Organizations and teams, labs that are evolving the fastest are building systems where every failure becomes another opportunity to improve the loop. Think about it. That's exactly how mature engineering organizations already operate. AI is simply accelerating that same cycle. But beyond software, this topic probably matters even if you never write a line of code, because loop engineering is about managing these systems. Your organization, your team, your work probably already operates in loops. Think about planning, executing, measuring, learning, adapting. That's continuous improvement, the loop. AI simply compresses those cycles dramatically. And those who understand this will build organizations that learn faster, that stay on the bleeding edge, where their competitors can't compete yet. This is the world where intelligence is becoming increasingly abundant, and speed, learning speed that is one of the few sustainable competitive advantages left. So if there's one idea that I'd like to leave you with today, it's that it's not about creating AI that never makes mistakes. It's about creating systems that recognize mistakes quickly, and they can recover intelligently and improve continuously, much like you must do in this age of learning AI era, because that's where scalability is coming from, which ultimately where leadership and personal growth comes from. And the organizations that thrive in this era won't simply build smarter models. They're going to be building smarter feedback systems. So until next time, stay curious, keep innovating, keep building the systems that help both people and AI learn, adapt, and create a better future together. This episode of Inspire AI Podcast is sponsored by Exponent 21. I keep hearing the same thing from business leaders lately. we're doing the work. But leads are harder to explain. Traffic is down, attribution feels fuzzy, and the old answers don't really fit anymore. What's changed is how people search. Instead of clicking links, people are asking questions, and AI is answering them. Tools like ChatGPT, Google's AI-powered results, and Perplexity are shaping which brands get mentioned, referenced, and remembered. Exponent 21 specializes in AI SEO. They help businesses understand how to show up consistently inside those AI-generated answers across questions about their industry, their services, and their brand. What stands out to me is that when people ask AI tools, who's leading in this space? Exponent 21 and its leaders are often referenced near the top. That comes from doing the work and shaping how this new search environment actually functions. To understand what this shift means for your business, visit exponent21.com.